guys, we're continuing on Unit 8. Today we're talking about limiting reactants. This is just a continuation of some of the stoichiometry that we did last time. So we're going to look at another recipe scenario. This says a cookie recipe calls for 2 cups of flour, 1 cup of sugar, 2 eggs, and half a cup of milk. It will make 30 cookies. How many cookies can I make if I have 8 cups of flour, 3 cups of sugar, and a dozen eggs, and 1 cup of milk? So basically, we can only make as much as like the smallest amount of the ingredients that we have. So we're kind of limited on how many we can make. That is called a limiting reactant. So what we can do here is very similar to what we did last time, where you write what you know on top of the equation. We're kind of going to do the same thing. So here's my equation. I can make a lot of proportions and kind of see which one I'm going to run out of first. So if I have flour first, this says I have 8 cups of flour. It said that on this question, or on this, on this question right here. We're gonna put that over the 2 cups of flour that's shown on this slide, the one that is in the actual equation. So if I divide those, that means I can make 4 batches with this part of my ingredient. Now we'll do the same thing for sugar. This says we have 3 cups of sugar. In the equation, there's only 1. Again, we can divide. We can make 3 batches with that much sugar. Next, I have eggs. I have 12 eggs. In the equation, there's a 2. So to figure out that, I would divide. That gives me 6 batches according to the eggs. And then for milk, I have 1 cup of milk. The reaction only calls for 1 cup of milk. When I divide those, you get 2 batches. So now I'm looking at these 3 numbers. I have 4, 3, 6, and 2. Well, 2 is my smallest number. So according to the ingredients that I have, which I circled, I can only make enough cookies for 2 batches because I'm going to run out of milk. Okay? So that means milk is our limiting reactant. We'll run out of milk first. A limiting reactant is also called a limiting reagent. We can tell because it has the smallest fraction. We use the limiting reagent to determine the amount of product that we can make. The limiting reactant or reagent in a chemical reaction is a substance that is totally consumed when the chemical reaction is complete. The amount of product formed is limited by this reagent since the reaction cannot continue without it. So let's look at an example. I'm just going to copy down my equation. I kind of have to do this in 2 parts. I'm going to put it a little bit farther down so that I have room to write. Okay, so just like before, I can write what I know from the question on the top. First, I have to figure out my limiting reactant. So that's what the question's asking for. It says that I have 18.1 grams of calcium chloride, and it says I have 0.41 moles of sodium hydroxide. So this should look very similar to what we did last class. My units on the top and the bottom need to match, so I can pull those down. For moles, you're always using your coefficient. For grams, though, I need the molar mass. So you may pause this video and try and find the molar mass. I got 110.986. So there's not an X this time. I just have my 2 fractions. So what that looks like, I need to divide each one to see which one I'm going to run out of first, just like what we did with the ingredients above. So I got 0.163. If I do the next one, I have 0.41 over 2. When you divide those, you get 0.205. So I'm looking at this number, and I'm looking at this number. Whichever one is smaller means I will run out of that first, and that's your limiting reactant. So here's my smaller number. That means CaCl2 is limiting. That means I can use that to figure out what my product is. So let's look at another one. Okay, let me copy this down. Okay, I'm gonna leave some space again. So the first thing I need to do is figure out what my limiting reactant is. Again, I'm gonna do exactly what I just did above. So I have moles here, and then I have 4.96 moles here. Okay, so since I have moles, I'm using my coefficient. So I have 2, I have 6. And it also wants me to figure out how many moles of hydrogen are formed. So I'll need that in just a minute. Right now, we need to figure out what the limiting reactant is. So I'm going to do 3.22 divided by 2. And that gives me 1.61. I'm going to do the same thing here. 4.96 over 6. That gives me 0.823. So you're comparing these numbers. The smaller number is your limiting reactant, which is this. So that means 6 HBr, I'm going to run out of that first. So that's the number, those are the numbers that I'm going to use to solve for the X that the question's asking about. So now I have enough to write a proportion. I have 4.96 over 6 equals X over 3. This X over 3, I'm just taking from that. So now I can cross multiply and divide. 4.96 times 3, and then divide by 6. I got X equals 2.48 moles. So that is your answer. You are using your limiting reactant to solve for your X. Let me kind of skip through these slides. Okay, so that's all I have on my slides. You also have an equation at the bottom of your page that says A plus B equals C plus D, and A is an excess, meaning that there's extra. Which one is the limiting reactant? So if I have, let's see here, A plus B equals C plus D, and A is in excess, there's only 2 reactants, right? So if one of them is in excess, then the other one is limiting. Those are your only options, limiting or in excess. So B is limiting. All right, guys, if y'all have questions, please shoot me an email. You guys have a worksheet to work on today and then work on your project.